Today we will learn about more details about transformer. This is the second lecture on transformer. In the first lecture we have discussed basics of transformer, primary winding, secondary winding, and how Faraday law of induction applies in this. In this lecture we will discuss more details about equation of transformer, voltage ratio, various types and applications. We have discussed electromagnetic induction, Faraday laws, electromotive force in previous lectures. We already also discussed self and mutual inductance, integral and differential form of Faraday law, and energy in static magnetic field. Transformer is one of the most important part of this unit and also very important for exam point of view also. At the end of this lecture, we will learn about basics of transformer, working how transformer works, how transformer transfer energy from one coil to another, then equation of transformer, we'll discuss about voltage ratio, types and applications where we use these transformers. I think all of you are aware of this. We all are working with electricity, and the electricity transformer plays very important role. Here, try to see the things why it is very important for us. Transformer is a boon for us to transfer electricity from one place to another place. In generation station, we generate electricity, and after generation, we use a step-up transformer so that we can increase the power and higher voltage. We use higher voltage to transmit from one place to another. Here, use three colors are used to distribution. In generation, we have used black, then in transmission we have used red, and finally in distribution we have used green. This also shows the various voltages. First we use step-up transformer for transmission so that it can increase the well voltage, and finally in distribution we use step-down transformer here, so the voltage reduced before to move to home and local distribution. Why before transformer I am discussing this, it is necessary that we have to change the voltage all the time. In home, for safety purpose, we use small voltage, but for transmission, when you want to transfer from one place to another, we use higher voltage. Now we come to this, our main topic, transformer. We have used transformer, we have shown transformer in the last slide. The transformer is probably one of the most useful electrical device ever invented. It can change the magnitude of alternating voltage or current from one value to another, that we have already seen in the last slide. This useful property of transformer is mainly responsible for widespread use of alternating current rather than direct current. In this, the electric power is generated, then transmitted and distributed in the form of alternating current. Yes, in home we can develop direct current also by battery cells. Transformer have no moving parts, rugged and durable in construction, thus requiring very little attention. No moving part is needed. They also have a very high efficiency, as high as 99%. We will discuss basic property of transformer here. In the transformer, we have two coils. And alternating voltage is applied to the first coil, that is called primary coil. When we apply alternating voltage to the primary coil, an alternating flux is set up. Change in electric field will give you magnetic field, that is called flux. And this alternating flux links both the winding and induces EMF E1 and E2 in them. E1 in the first binding, E2 in the second binding. And according to Faraday law of induction, this E1 is termed as primary EMF and E2 is termed as secondary EMF. EMF is electromotive force. We have discussed this in previous lecture. In the figure, the primary and secondary coils are shown. The voltage that we have applied is also shown here. This voltage V1. And this is primary, this is secondary. Due to this volt, the EMF created, this is denoted by E1 and on this side is denoted by E2. Depending on number of turns and secondary N2, an alternating E2 is induced, and E2 is in the secondary causes secondary current I2. Now, if you get more voltage than the first, that it is called step up transformer. If you get less voltage than the primary, this is called step down. So we have two types of transformer, step up and step down. Sometimes we want to decrease the voltage, then we use step down. If we want to increase the voltage, we use step up. We know from the Faraday law of induction that E1 electromotive force in the first primary coil is equal to minus N1 d phi by dt. N1 is the number of turns and phi is the flux change. D phi is the flux change with time. Similarly, E2 can also be written as minus N2 d phi by dt. If you divide these two, since d phi by dt is same, you will get E2 upon E1 is equal to N2 over N1. E2 upon E1 is also indicates V2 over V1, as we have already discussed. So by this we can check whether it is a step up or a step down. Transformer action is based on laws of electromagnetic induction. And there is no electrical connection between primary and secondary, even they don't touch each other. Then how power is transferred? This is through magnetic flux, change in magnetic flux. We are using this principle. There is no change in frequency. Output power have same frequency as the input. The loss that occur in the transformer have two types: copper losses and core losses. Core losses, when we keep something in the core, when we wrap the coil on some material, that we have this type of loss due to eddy current with opposite changes, and hysteresis loss. Copper losses basically is the resistance of winding. It may have some resistance, that is called copper losses. Suppose we are applying V1 voltage and the voltage is sinusoidal voltage, alternating voltage. We can treat this voltage as phi m sin omega t, and where f is the frequency, omega may be 2 pi f. Now when primary winding is excited by alternating force V1, it is circulating alternating current, and this produces alternating flux also. The details are given in the figure. Suppose the flux that we are applying is instantaneous alternating current we are applying, so maximum flux is phi m. N1 and N2 are the number of turns in primary or secondary. If f is the frequency, that frequency can be written here, and E1 and E2 are the RMS value of EMF. From Faraday law of electromagnetic induction, the average EMF per turns can be written as d phi over dt, where d phi is change in flux. Here phi is missing, so I am using d phi, and dt is time required to change in flux. The flux changes from 0 to maximum value in 1 by 4f of the time period, as we have seen in the last slide. So that is 1 by 4f seconds, and the change of flux takes place in is phi m, from 0 to phi m. So the d phi by dt can be done as dt upon 1 for 4f and 4f phi m Weber. In complete cycle, d phi is phi here, so you can use it, this phi, so 4f phi m, this is Weber per second. The flux varies sinusoidally, and the RMS value can be calculated. Form factor of a sine wave for RMS, and we know this, that RMS value and average value can be done as 1.11. Now the RMS value of induced in one turn may be the one turn change is 4 pi f, then this will be the RMS value in volts, and this will be also equal to RMS value of EMF induced in primary welding. This can be calculated because using this by multiplying by N1, since number of turns in N1, so we can calculate. And similarly we can also calculate in N2 with in secondary using the number of winding N2. So we have, now we know these two. The equation that we have obtained, V1 is equal to 4.445 m and volts, or V2 is equal to E2 4.445 f and 2 volts, are called equation of transformer. It is used to calculate the values. If we divide these two equations, we will get E2 over E1 is equal to 4.44 and everything. If we write this, then we will get E2 upon E1 is equal to N2 over N1, or V2 upon V1 is equal to N2 over N1. This ratio is termed as K. This is also known as voltage transformation ratio. If some voltage is transferring from transformer, in a transformer from one primary to secondary, this will give you the idea of transformer ratio. So the transformer ratio of an EMF induced in secondary winding to the secondary winding to the EMF focus in the primary winding. So basically it's a ratio of EMF in the second winding to primary winding, and this gives the idea if N2 is greater than N1, if we have more folds, more turns in second than 1, then K will be higher. It means E2 will be higher. It means that is called step up transformer. In step up transformer, the second coil will have more turns than the first. Whereas in step down transformer, N2 will be less than N1 and you will get E2 will be less than E1. So in the step down, we must have less number of turns in the second coil. By using relative ratio, we can calculate these values. In the last lecture, we have discussed ideal transformer and real transformer. Practical transformer or real transformer differs from the ideal in many ways because the transformer may have iron losses, winding resistance, and magnetic leakage. Iron losses, since the iron core is subjected to alternating flux, there occur eddy current. Generally, we prepare the coil by wrapping a wire on either on the hollow place, hollow something, or some metal. Suppose you are using iron, then in that iron, due to alternating current, a new currents are formed that is called eddy current, which opposes the changes, and also hysteresis may be occur. Charging and discharging both will be there, and these losses together known as iron losses or core losses. The iron loss depend on supply frequency, maximum flux density in the core, volume of the core, etc. It may be noted that the magnitude of iron losses is quite small in practical transformer. And the loss that may exist in transformer is winding resistance. Winding resistance. Winding consists of copper conductor. It immediately follows the primary and secondary will have winding resistance. The primary resistance R1 and secondary resistance R2 act in series with the respective windings. When current flow through the windings, there will be power loss due to IR. This will affect the power factor and E1 will be less than V1, while V2 will be less than E2. That is why we observe winding resistance. Transformer have basically two types, core type and shell type. In closed core type transformer constructed in core form, when windings surroundings the core, we have a core and we wind the same thing. That in the transformer in shell form, we design such that the core is outside the winding as it is shown in the second. In single phase transformer, we have shown two coils. In the third phase, we have three coils. Similarly here, single phase, only one coil, and then three coils. In laminated core transformer, these type of transformer used at power and audio frequency transformers and typically have core made up of high permeability silicon steel. The steel has permeability many times that of free space. And the core thus serves to greatly reduce the magnetic current and confine the flux of a path which closely couples the windings. So this type of transformer created for audio frequencies and power amplifier. From the above text, our discussion, we have come to the conclusion that the transformer have many types: step down, step up, and then at the base of application, power transformer used for basic more power. If it needed, we use power transformer. Distribution transformer we use to distribute electricity. Single phase transformer and three phase transformer on the base of utilization. Then instrument transformer, current transformer, and potential transformer. Sometimes used to change current and potential. This is used in various instruments. In this figure, many types of core are shown. Suppose air core is, if we use air core, then there is nothing in this primary and secondary coil. But if we use iron dust core, then it is shown here with the dashed line. In air core is used for above 1 megahertz, but here this is 100 to 1 megahertz, 100 kilohertz to 1 megahertz. Iron core is used for audio and frequencies. More iron is there. Then center tape, this is shown here, center tape. If you want two values or divide something, then we use center tape. Addition is there. If we want, there can also be an option that two or more secondary is there. Two secondaries are here in the only first primary. This is called auto transformer, which can give you any values on the basis of, we can change this value, we can move this to get any values. We have discussed this step down and step up. In step down, primary have more turns than the secondary, and step up, primary have less turn than secondary. Primary is in series for 230, and parallel for 115. Here we have some additional features. If we want to use some thing in UK and USA both, then 230 and 115 is given, because in USA we use 110 voltage, and suppose you are doing the same device, then it is used for in the both cases 110, 220. Then side transformer, earth and center tape. These are the various types. Here again a kind of auto transformer is shown, where various values can be obtained. So we have studied transformer, its types, equation of transformer, voltage ratio. It is suggested to take study or references from other books, textbooks, and also do some numericals.